Okay, sorry, I lost 10 seconds trying to figure out where and what. So, here we go, guys. Today is Saturday and nobody showed up at the session. I know you're not required, but I was planning actually to help you with lab 4 because this is a relatively easy lab and we could have gone over it like in 10 minutes. But, you did not show up. So the best thing that I can do right now is try to review some questions for the midterm. Please look at assignments, start submitting assignments, check the announcements. Some of you didn't even log in into the class yet, and this is week 3 finishing. You are required to spend between 4 and 6 hours, and none of you is even close to that. Starting week 5, I will make the discussion a requirement for participation points. Because as it is right now, I can't even give you participation points because you haven't been communicating with me. Just few people are submitting assignments, basically 1 or 2. The rest of you I haven't heard from. There is no activity on your account, no assignment submitted, which is absolutely not okay. So week 5, I'm going to make the discussion a requirement to earn participation points. You have to email me. You have to somehow do activities. Either go over the PowerPoints, watch videos, submit assignments. This is asynchronous class, so in order to get your participation points in attendance, you have to be here and you have to be doing something. Plus, physics is very difficult. You need time to understand that. And as hard it is for me, I'm dedicating my Saturday to try to help you, but nobody shows up. So please, at least send me questions, text me. And here you go. Now we're going to review certain things for the midterm. I'm trying to help. Okay, first thing is understanding free fall. It's called free fall, but it's neither free nor it's a fall. It basically means motion. We're not even saying up or down. Motion under the influence of gravity alone. So no other forces are participating but gravity. You don't have a visual for acceleration. This is one thing you have to understand. So when you see someone, for example, moving fast on the freeway, it doesn't mean that he has acceleration. He might be moving at constant speed, but a very high speed. Yes, you can tell the speed. You can tell if someone's moving fast or slow. But in most cases, you cannot tell if they have acceleration or not. So don't use your senses to judge the acceleration. So there are several misconceptions that I want to pay attention to here, and especially for the midterm. The first one is try to decode what the problem says. All of you have a problem with putting the given using formula. In physics, we don't use numbers. The numbers come at the very last line of solving problems just to check if we get a reasonable answer. We don't use numbers. Some problems don't even have numbers. If you look to the examples that I'm giving you each week, you're going to see that some of the problems are solved without any numbers. Obviously, some of you are not looking at the videos, not looking at the examples. All of you mess up the significant digits. It seems that you are understanding the significant digits because week 1 there you correctly identified. And then when you start solving problems, the significant digits go away. Understand that your answer does not make sense if you don't have the appropriate significant digits there. I posted problems, how to solve problems in physics. None of you is doing that. Maybe I'll make another video after this one to show you how to solve the problems. The second, starting from rest means initial velocity is 0. Stopping something, a car or something is stopped, means final velocity is 0. When an object reaches maximum height, again, you don't have a visual for the acceleration. You can tell that the object is stopped for a moment. Because if it reaches maximum height, it means after that it's going to start to fall. And yes, at that particular moment, velocity is 0. That does not mean the acceleration is 0. Not having a visual for that. How long in a problem means you're looking for time. How fast, you mean you're looking for velocity. Believe it or not, you have only 3 formula for kinematics. I don't like the second one that you see there. You have to be very careful if you decide to use the second one because it's tricky. Even I don't use it. So you technically have 3 formula. The first one, which is for velocity, if your problem contains only velocity, mentions no distance or displacement. And the last 2 are actually for displacement. This delta x that you see here, it's finding the displacement. But if you notice, the last one doesn't have the time. So if you're dealing with displacement, but you have no information about the time, you have to use the last one. If you have information about the time, then you'll have to use this one. This is it. 3 equations, but they can have a very different form depending on the situation. Because your initial velocity could be 0, then this will go away. And this one here will go away. Or it could be that you don't have acceleration. So then the distance just becomes b times t. So they can form different situations and they can be applied differently, but you have 3 equations. This is it. Now, make a difference between speed and velocity. Speed is a scalar, velocity is a vector. So when you're dealing with velocity, you always have to think direction. Make also the difference between mass and weight. Mass is a scalar, weight is a vector, which means that the weight has direction always toward the center of the earth. Weight means gravitational force. This is it. The gravitational force acting on you, it's called weight. So always points to the center of the earth, or on paper that means down, and it changes because gravity is different on different planets. Mass doesn't change. Mass is basically the substance that you have in you. Know the formula for work and power. You're gonna need them to calculate. Most of your problems, though, are gonna be on forces and understanding Newton laws. They're easy to say, they're hard to understand. Your first law basically says that if there are no forces acting on you, you will continue traveling in a straight line with constant speed. That's what it means. Exactly the opposite of what Aristotle taught, that in order to move, you have to have some force applied to you. That is counterintuitive. It basically, all physics is counterintuitive, which means common sense. It is not going to help you. So every time you're dealing with forces, you also have to think direction, because they're vectors. This is pretty much the main things that you need to understand. Know the formula also for kinetic energy, for potential energy. Understand the concept, the relationship between energy and work. You have everything in the PowerPoint. I suggest you make yourself a list of formula, maybe, that you can use. I also posted some. You can use them. Although you have much more than you need, you might get lost into them. But so that's why I suggest you make your own list of formula to use, which is potential energy, kinetic energy, the 3 kinematics formula, the forces in terms of like friction force, tension force, then power, work, That's pretty much, you don't have that many formula, and most of the time it's not about formula, it's about understanding the concept, because you also have conceptual problems on the midterm, but they all gonna fall into those topics: energy, work, power, kinematic equations, and forces. Okay, so I'm gonna finish this video, and I'm gonna try to make a video where to show you how to solve a problem in physics, so you can follow that model, although you have other videos of other people that I posted that you should follow.